Welcome to the first lesson of the SolidWorks Essentials course. In this lesson, we will look at the basics of using SolidWorks and discuss the user interface. SolidWorks is a feature-based design software. This means that features are used as the building blocks for creating the parts that we would like. Let's quickly take a look at the part in front of us to see what this means. We'll go through the part step by step to see how these features can be used. Features can firstly be used to add geometry to the part. This is done by using sketches to define the shape of the geometry. Using sketches, we can also remove geometry from the part, as can be seen using this cut feature. In this way, we can use as many features as are required to create the geometry that we would like. We can also make a distinction between parts that require sketches for creation, also known as sketched features, and applied features, which are features that does not require sketches, such as fillets and chamfers. SolidWorks also keeps track of all the features that we use to create the part, so that we can edit these features at any point. SolidWorks is also a parametric design software. This simply means that the geometry of a part is specified by dimensions, and that any change in these dimensions will lead to a change in part geometry. Let's quickly take a look at how changes in the part dimension will change the resulting geometry. Let's quickly change the length as well as the distance between the letters to see the effect on the part. Let's cancel this for now to keep our original part geometry. SolidWorks is also fully associative. This means that any changes made to the part will also show up in the associated drawings and assemblies, including this part. It also means that any changes made to this part within the context of the assembly or the drawing will show up in the part file. Let's quickly take a look at how this works. If we go to the drawing of this part file and decide to make any changes to the dimension of this part, after rebuilding the drawing, we will see that the changes are reflected within the drawing. If we then move back from our drawing into our part file, we can see that the changes made in the drawing is reflected in our part file. SolidWorks also has powerful tools that allow us to capture the intent of our design. Design intent is an important topic, so let's quickly take a look at an example. Here we have two identical simple brackets. The intent of our design here is to have holes on the edges of the brackets that are in the middle of the bracket vertically and a specified distance from the edge horizontally. Although both brackets are identical at this point, the effective capturing of design intent will become evident once we start to change dimensions. For example, on the left-hand side bracket, we use dimensions to specify the hole to be in the middle of the part vertically. This means that if we change the dimension to something else, the hole will no longer be in the middle. However, on the right-hand side, we used construction geometry and related the construction geometry to the midpoint of the vertical line. This means that once we change the dimension, the whole of the bracket stays in the middle of the part. We can also change the length of the part and see how the part updates according to the specified relations. On the right hand side, we captured the design intent correctly by using construction lines set equal to each other to ensure that the holes remain a specified distance from the edge of the bracket. We can also use equations to capture the intent of our design. Let's say, for example, we want the holes to be 1.5 times its diameter from the side of the part. If the intent of our design has not been captured, no changes will be made when we change the diameter of the hole. However, if we used equations to accurately capture the intent of our design, updating the diameter of the holes will automatically ensure that the rest of the part is also updated. It should be evident from this example that capturing the design intent from the start will aid greatly in reducing design time. Considering the intent of your design is not only important in sketching, but also in using features. Let's quickly take a look at another example. In this example, we have a simple part resembling a shaft. Let's quickly look at how this part was constructed. When looking at the history of the part, we can see that the different features was constructed one on top of the other. This can be useful if a part will simply be 3D printed or otherwise additively manufactured. However, this exact same part can also be created by using a single sketch and revolving the sketch around its center axis. Although this method might seem very efficient, be careful of using a single complicated sketch to create your part. This might make editing quite difficult in the future. A third alternative for creating the same part is by using what could be seen as a conventional manufacturing approach. We start off with the stock of the part and then remove the features as is required. Note that all three of these methods created a part with exactly the same geometry. However, going back to edit the part will be different for each instance. The last thing I want us to shortly discuss before we start looking at the SolidWorks user interface is the placing of excessive detail on standard components. Although SolidWorks has the tools required to create extreme detail, these features should not be used for modeling standard off-the-shelf components. This is especially true for assemblies and will most definitely negatively impact your hardware performance. Now that we've discussed some of the basics of using SolidWorks, let's quickly look at the user interface. When starting up SolidWorks, you will be greeted with a welcome dialog box. From here, you can create new part, assembly and drawing files, as well as access your recent documents or open any other documents. If you would not like this welcome dialog box to show on startup, it can be disabled. For now, let's start a new part. At the top of our SolidWorks user interface, we will find our menu bar. Our menu bar includes various pull-down menus that can be customized, as well as standard operations like creating a new part, opening a part, saving a part, or printing. Right below our menu bar, we will find the Command Manager. The Command Manager has various tabs. These tabs are used to group together features that might be used often, such as features, sketches, as well as other things like sheet metal and weldments. The tabs that are shown in the Command Manager can be modified by simply right-clicking on the tabs, going to the tab drop-down and selecting the tabs that we want to view. Next, on the left of the screen, we have what we call our Feature Manager design tree. In the Feature Manager design tree, we can find all standard components that are inserted into every new part, such as the part origin, its standard planes, and its material properties. Here you will also find a chronological list of all the features that were used in creating the part. As we saw earlier, the Feature Manager design tree is also available for part files, assemblies, and drawings, with the content varying based on the file type. We are also able to select, edit, and delete features from our Feature Manager design tree. In the same position as our Feature Manager design tree, but just in a different tab, we can find our Property Manager. The Property Manager will activate automatically once we activate any tool within SolidWorks, thereby enabling us to execute active commands. In the same position as our Feature Manager design tree and our Property Manager, we can also find our Configuration Manager, DIM Expert Manager, and Display Manager. We will discuss these later in the course. On the right of our screen, we can find our task pane. Our task pane includes our design library, which will include our toolbox for SolidWorks Professional and Premium, our File Explorer, which we can use to open files, our View Palette, which is used for drawings, and our Appearances, Scenes and Decals tab, which we can use to apply scenes, appearances and decals to our part. Our task pane could also contain other tabs based on add-ins that can be installed. Also note that we can pin the task pane to prevent it from closing when we click in the graphics area. The rest of the screen we refer to as the graphics area, as this is where the graphics will be displayed. In the top middle of our graphics area, we can find our heads-up view toolbar. Various viewing settings can be found here. For now, it's only important to note that this will only change what we see and not the part itself. Let's for a moment go back to our command manager. In our features tab, we will see that some features are available to use while other features are grayed out. The grayed out features is simply SolidWorks' way to tell you that these features does not have the prerequisites needed to use these features. Let's quickly open up one of our recent files to discuss how we use the mouse and keyboard in SolidWorks. In SolidWorks, the left mouse button is used only for selection. We can also use box selection, as is standard for Windows. Right-clicking on any item will activate the shortcut menu. This shortcut menu is context sensitive and will change based on the item on which you right-click. Our shortcut menu consists out of our context toolbar and shortcut menus. Our context toolbar will also become available upon a normal left-click selection. Next, let's quickly discuss zooming, panning and rotating in SolidWorks. To zoom in or out in SolidWorks, we simply use the scroll wheel. Note that it will zoom to the area in which your cursor is. To rotate our part, we can simply hold down the middle mouse button and move the mouse to move the part into the orientation which we want. And lastly, to pan, we can hold down the control key while holding down the middle mouse button and moving the mouse around. If you have previous CAD experience and it seems like the zoom direction for SolidWorks is counterintuitive, you can change this by simply going to Settings, Options, moving to the View tab and selecting Reverse Mouse Wheel Zoom Direction. SolidWorks also has mouse gestures and keyboard shortcuts that we can use to work faster in SolidWorks. We will discuss this later in the course. For the last part of this lesson, I would like us to quickly look at how to open, close and save files in SolidWorks. Firstly, I would like to note that SolidWorks conform to Windows keyboard shortcut keys with Ctrl-O and Ctrl-S that can be used to open or save a part. Let's quickly take a look at where to find this in the user interface. To create a new file, simply go to File and click on New. From here, you will be able to select whether you want to create a new part file, assembly file, or drawing file. I'm going to cancel this for now. To open an existing file, we can also go to the File drop-down and go to Open. From here, we will be able to browse for the files that we want. Let's cancel again for now. Lastly, to close, we have two different options. If we simply want to close the file that we're currently working on, but keep SolidWorks open, we can use the cross in the top right of the graphics area to close the part but keep SolidWorks open. If we would like to close the SolidWorks program, we can close it by clicking the cross in the top right corner. This was the lesson on SolidWorks basics and the user interface. In the next lesson, we're going to start looking at the basics of sketching in SolidWorks.